I want to talk to you guys today about another way to accomplish cycle time, and that is through buffering. And what is buffering? Buffering just means to prepare more product so that it's ready for the operation to happen on the next cycle. So let's say, for instance, we're picking up one product, right? You have a robot pick up the product, placing it. When the robot goes back to pick up the next product, if the next one is not already there, then you've now created a bottleneck for that operation. And by having a bunch of different buffering stations, you can now allow for there not to be a bottleneck. And I'll give you an example of if you had no buffering whatsoever, what that would look like. Essentially, you would have to pick up a part, move it to the next area. Something would have to pick it up from this area and then move it to the next area. Then you can pick from this area over here and then move it over, right? So everything has to go in a way where it has to follow the thing in front of it. So this thing has to move over for this thing to move, to this thing to move, to this thing to move, right? If you don't create buffers, and the more amount of buffers that you create, you can generally create a better flow for your system. This can also help with, especially if you can like build out a mass amount of buffer. And what does a massive amount of buffer means? A massive amount of buffer would be a buffer that gives you an extended period of time, right? And that may be somewhere between like 15 minutes, maybe 20 minutes, maybe an hour. And you could even build a buffer and be taken offline and be stored somewhere to where now it's actually making hours or days worth of extra product. And why would you do something like that? Well, maybe you have an upstream portion of the line that is slower, right? For some reason it got designed where the front end of the system it just couldn't match the speed of the back end of the system. And so now this back end of your system is able to produce, let's say, double the amount of product that the front side of the system can process. Why would you not just slow down the front side of the line? Well, the reason why you may not want to slow down the front side of the line is, what do you do whenever the front side of the system goes down? You know, you're then stuck. You're stopped. Your whole entire line stops. No production throughout the entire line. What do you do when the back end of your line goes down? Okay, slowly everything will trickle out, as much of the system that can, from wherever your stop point is to, you know, all the way to the front of the system, the end of the system, I should say. It's going to run all that product out, and then the line's going to be down, right? If maintenance hasn't gotten over there to fix whatever the issue is, and now the system can no longer run. So what you can do is, with that buffer that you've built up, you can now start introducing that buffer back into the line. Project like this, where essentially, literally all the project was for was to do buffer. Take product off of the line, shall the line never go down, stack it off into a skid, and then stack it back onto the line, shall the line ever match the line speed again. Now, we've done a couple different variations of this. We've done variations where we just build buffers that then get taken off and stored to another location, or we've built buffers where it just builds out a certain amount of build time. Maybe it's like 2 racks worth of product, so it's like 2 extra hours of runtime. So shall the front end ever go down or the back end ever go down, it can reintroduce that product for a couple hours of runtime. But then there's the other version of buffering. So buffering, where it comes to the pick into place, right? So if you always have a robot that's over there waiting for the product to be there and in place, then it may make sense that you have 2 pick stations, right? So a pick station A and a pick station B. Let's say, for instance, you don't have an issue with the cycle time, the system upstream. You just have an issue with that product making it. Maybe it takes 10 seconds for the product to get from this station to the robot's pick station. So instead of one product getting to that robot pick station and then this other product just sitting back here somewhere, now it can come over here and start coming and come to the pick 2 station of the robot. And during that whole entire period of time, while this second product is coming to the pick 2 station of the robot pick position, the robot is in motion, grabbing the product, placing the product. By the time it lets go of the product and goes to pick up a next product, number 2 is ready for the robot to pick. And in that same time, while all that's occurring, there's already one that's been traveling to position 1 again. So that way, once it runs and drops off 2, position 1 is available. Now, this can be done with multiple different parts. I mean, this is where you can really speed up the line by adding like 5 stations. And instead of the robot only picking up 1 part at a time, the robot picks up 5 parts at a time in its tooling, places like 5. And then maybe you need 2 buffer stations, and each one of those buffer stations have, 5 parts each. I'll give you different scenarios of different types of systems and different levels of buffering that may occur. The buffering is huge when it comes to having an automated system that operates really smoothly and that eliminates downtime. So keep that in mind when it comes to like maintenance and when it comes to just downages on your systems for any reasons. And I'll give you one last reason why you need to have buffering. Going back to the more long-term buffering, you can utilize that as day off, right? You can use that for more productivity without using as many employees. So what do I mean by that? In a scenario I gave you before, where the front side of the line couldn't keep up with the back side of the line, right? So the upstream was running too fast and buffering all that extra material and storing it in inventory. At the end of the week when Friday rolls around, everybody goes home, but then on Saturday and maybe even Sunday, you have operators come in and run that second part of that line, the end half of that line. So that way they can process through that buffered material, but you don't have to have any of the employees to help process any of the material on the front half of the line. So now you could have essentially cut your amount of employees required by in half, or it could be even more than that if the front half of your line was a very labor intensive portion of the operation and the back half is a very less labor intensive operation. So not only can you buffer for seconds, but minutes, hours, and days. So keep those things in mind. Hopefully it helps you have a better automated system. If you need any help with these types of systems, feel free to reach out and let us know. Have a good one.